Okay, this is lesson 9.5, applying the Pythagorean theorem for 8th grade students. We've already learned about the Pythagorean theorem before. We've talked about it. We're going to try to apply it to real world situations. So, let's solve some problems using the Pythagorean theorem. So, the next slide talks about a right triangle. Right triangles are the type of triangles we can use the Pythagorean theorem. The longest side of a right triangle is called the hypotenuse, and the other two shorter sides are called the legs. We assign the hypotenuse variable c and the two legs a and b. Okay, and you probably remember all of that. So the Pythagorean theorem is, and it's a theorem, remember, is a proven rule in math. The Pythagorean theorem describes the relationship between the legs of a right triangle and its hypotenuse, and it has to be with a right triangle, and in which case a squared plus b squared equals c squared. So we're going to use this. Okay, so you guys got a glimpse of what this example is going to look like. We have a television, and television screens are usually measured by the diagonal length. If you have some people have like a 42-inch flat screen TV. That's not, if you've ever looked at it, it's not 42 inches wide or tall. It's just, it's 42 inches diagonally. So that's how TVs are measured. Well, we can find these measures using the Pythagorean theorem. So if we have a screen that has a width of 21 and a length of 31, let's go ahead and draw this situation out and find the diagonal measure. So we have 21 inches, 31 inches, probably should say the height and the width, but we have width and length. That's fine. Those are the two legs of a right triangle. So we have this right triangle, and we're going to call 21A and 31B. And so we want to find the diagonal. So a squared plus b squared equals c squared. Okay. And then I forget I could do that. Okay, so 21 squared plus 31 squared equals c squared. And I forgot to label that c, so let's go ahead and label that c. Okay, let's find these. 21 squared. Okay, 21 squared is 441. Plus 31 squared, which is 961. That's all equal to c squared, according to the Pythagorean theorem. So let's go ahead and add those two together. And we get 1,402 is equal to c squared. So if we want to, and this is a review from what we've talked about even in the first section. So if we want to solve for c, we need to take the square root of both sides here. So the square root of c squared is c, and the square root of 1,402. Okay, so the square root of 1,402 is 37.44 rounded to the nearest hundredth. So we would say 37.44, and we are talking about inches here, so be careful when you do this. Make sure you describe it in inches. Okay, let's move on to the next one. Let's go back. Sorry about that. So the next example is about a boat ramp, and it starts 4.2 feet above the water, and the distance from the edge of the ramp to the end of the edge of the ramp to the end of the ramp is 25 feet. So let's draw this ramp. So we have this ramp. Not a very good drawing here, but we'll just take it. We have the height is 4.2 feet. And the distance from the edge of the ramp to the end of the ramp is 25 feet. So 25 feet. and you want to find the length of the ramp. So again, a squared plus b squared equals c squared. I think you guys can kind of handle that. We'll go ahead and show that real quick. So we're going to use a squared plus b squared equals c squared. 4.2 squared plus 25 squared equals c squared. You get 17.64 plus 625. You add those together, you get 642.64. Take the square root of both sides, and you find out that the length of the ramp is 25.35. Obviously, our picture isn't very good because the ramp is just barely any more than the length from the end of the ramp to the where you would get up on the dock. And so, or what the heck am I saying? Anyway, the length isn't very much different, but over that long length, you get this 4 feet differential. So ramps are quite useful. All right, let's try another example. Here we have three-dimensional figures where we can find the missing lengths. Now, in part A, we have we're given the height of a triangle and the base of a triangle, and it's a right triangle. Oh no, we're not given the base, but we are given the hypotenuse of this right triangle. So now we're going to use a squared plus b squared equals c squared, except we're going to have to do some subtraction. So let's show you how that works. Okay, so we have a squared plus b squared equals c squared. We call x a, and we're going to call b 28, or 28 meters b. The hypotenuse is 39. So 28 squared is 784. 39 squared is 1521. Minus 784 from both sides, you get x squared is equal to 737. Take the square root of both sides, and you get x is equal to 27.15. Okay, let's try the other one. Okay, so in this example B, we have to find the diagonal of the bottom rectangle, and we have a right triangle there that forms that diagonal where one of the sides is 5, the other is 12. So we're going to find that, and so we take 12 squared plus 5 squared equals c squared. 144 plus 25 equals c squared. You get 169 equals c squared, and so take the square root of both sides, so 13 equals c. So that's now the leg of the other right triangle, which we're trying to solve for x. So 13 squared plus 20 squared equals c squared, which is 169 plus 400 equals c squared. So 569, take the square root, you get that x, actually I shouldn't have put c, is 23.85 inches. And there you have. And I think that's the end of the note, so good luck, guys. And then we'll have a little bit of work time, and then we'll move on to 9-6.